Welcome everyone. So this is our 43rd live stream geometry and counting. And today we have two people here with us so far, possibly more will join later. And I'm going to do more problems from some various mock contests. So I tend to find that problems from the geometry mock contests tend to be harder than just normal contests. And I didn't pick them all from just one single contest. I sort of spread them out this time. So it should be fun. And with that, I will get started. Let me share my screen, give it just a second. All right. So here's the first problem from the GJMO. I'm not sure what contest this is, but I found it on AOPS on a list of mock contests. So I'm going to start drawing it.
Good evening, Michael.
Hi, Dat. Thanks for joining.
Yeah.
So this is just the first problem, so we just got started. So I'm not sure exactly what contest this is, but it's some mock contest. So we have triangle ABC. Oh, I3435 created this. All right. He usually has some pretty good problems. I think one of my viewers might have actually recommended this problem to me earlier. K is the intersection of the angle bisector and BC. So yeah, if you already know the solution, don't give it away. Oh, whoops, my bad. So this is K. H is the orthocenter. I usually just like drawing it using the algebra tool. So that should be 4, I believe. Yes. The line through K perpendicular to AK, so we draw that. And it meets AH at a point P. And then we draw the line through H parallel to AK. Whoops. Sorry. Let me close this. And it meets the A tangent. Okay, so we want to draw the circumcircle of ABC. And we want to draw the tangent at A. And it meets this line at a point Q. And we want to show that PQ is parallel to the A median. All right. Interesting. So let me hide a bunch of stuff so that the figure looks nicer. Now hide this, 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 and this. And it's tangent. What else do I draw? AK is the angle bisector. That's a right angle right there. And the parallel through H to AK. So HQ is parallel to AK. And we want to show PQ is parallel to the A median. So maybe I should draw the tangents. Tangents at B and C. Hold on just a second. And it might be worth extending AH to meet the circumcircle. So I'm going to do all that. All right. So let me draw the foot of the A altitude. So HE equals EB. And draw the two tangents at B and C and let them meet at a point.
And you also draw median.
Yeah, so I'll do that too. So AG is the median. So we want to show PQ is parallel to AF. And we know that angle FAK is GAK. So we have a few things to start out. This angle PQ.
P
Sorry.
is the under point, not that is a.
Oh, P. I'm sorry. So P is this point, not that point. What were you saying?
Yeah, you are drawing QE, not a QP.
Yeah. All right. So I wonder if angle PQH equals angle KAG. I don't think so. I think it's bigger. So that's 4.33. Oh, they are equal. Okay. So somehow we want to show angle. So I guess first we could show that AK is parallel to QH. So QH is parallel to the angle bisector. Oh, that's given in the problem. Okay. So yeah. Let me see. Maybe it might look nicer if I do a flatter. I'm not sure. Yeah, it's a tricky diagram, but I don't want E and P to be too close.
I think E is not necessary in this problem. Where you could delete it.
You could delete it. Yeah.
Yeah. Yes. Could you draw the center of ABC?
Yeah. Call it O.
Yes.
So, oh yeah, OG and F are collinear, obviously. We'll just draw that in. Also, AK passes through this point. So yeah, it's probably worth drawing that. So we want to use that angle AKP is 90 degrees. Yeah, so we could try to show triangle QHP is similar to triangle triangle AEF. Is that right? I think so.
Can you extend AO to meet BC?
Yeah. Oops. And maybe we could do something with homothetes because we
Well,
want to. Oh, I'm sorry, go on.
it is enough to prove that AGI and QPA are similar.
QPA.
Yeah, QPA.
Okay.
Now we know the angles QAP and AIG are equal. Then we can write ratio.
Okay. So QAP is equal to angle AIG. So you said that would solve it. Is that some spiral similarity thing? I think it is.
Well, if we prove the similarity, then we will know that GAI equals to QPA and GAI equals to DAF.
Okay.
And we are done.
And so that would solve it. That makes sense. All right. So do you think you've solved it, or that's kind of the idea of writing ratios?
If we prove the similarity, then we are done, but I don't know how to prove it.
Okay. All right. So let's see. QAP and AIG. So yeah, we have to use somewhere that H is the orthocenter.
Actually, calculating AP is not that hard.
Calculating it?
Calculating AP is easy, but AQ is not that easy.
AQ is harder, right? Yeah. Yeah, so we want to, let's see. Yeah, I think the hard part is using the fact that H is the orthocenter. Yeah, I was wondering if we could do something with homotheties. So we want to show a triangle QHP is similar to AGE. Whoops, sorry. So let's check it. So does that mean that these three lines concur? I'm not sure. No. Are B, P, and E collinear, or is that just a coincidence? Looks true, but let's see. Oh, it's not true. And I let QA intersect BC. Yes. See if we have any collinearities. No, it doesn't look like it. Oh, wait, I'm trying to think. So we want to show triangles QHP and AEF are similar, right? And their sides are all like parallel. Like we want to show that. But if that were true, then by Desargues' theorem, shouldn't EH and PF concur on AQ? Yeah, so they do. Maybe we could show that. We show EH. Okay, so yeah, we want to show that EH and FP meet.
How did you conclude? I didn't understand.
Oh, so yeah, if we can show EF and EH and FP meet on AQ, then by the converse of Desargues, I think we could solve the problem, because basically, so I'll start from the beginning. So do you agree if we can show QHP and AEF are similar, then that would solve the problem? Because QH was defined to be parallel to AE. And we want to show that QP is parallel to AF, right?
Yeah, I see.
Yeah. So EH seems a little bit easier to work with. But yeah, FP, yeah, I'm not sure. So maybe we could let EH and FP meet at a point. Or maybe we should let FP and the tangent meet at a point, and then we could show that's collinear with H and E. Not sure what's the best way to go. But let's see if we can say anything about that point. So I wonder if this is a perpendicular. So if FP is perpendicular to AJ. I don't think so. No. I guess we could try to let FP meet the tangent at a point and then calculate the distance LA. And then we could let EH meet the tangent and then calculate that distance and show that they're the same. Just an idea. Yeah, let me draw that point in just one more time, just to see if we can say anything about it. Because that kind of seems like an easier problem. Show that EH and FP meet on the tangent. I don't know for sure that it's easier, but
Actually, it seems that trigonometry can help, but it wouldn't be a nice solution. We can calculate QH by sine law.
okay. Maybe I'll still write it out because maybe that might give us some idea. So we can calculate QH. Is the idea in the end to find similar triangles?
The idea is to prove that QH over HP equals to AE over EF.
Ah, okay. So we can calculate QH using the law of sines, and then HP. Do you see how to compute HP?
First calculate AP, then AP minus AH.
Okay. That makes sense. Hold on a second. Let me just try something and then I'll see if we can do that. EP. Okay, so yeah, we'd calculate AP because we know that AK squared, like if we let, like if we label the foot of the altitude, then that times AP would be AK squared. I think it might be a little tricky doing it that way. Yeah, let's first see if we can do it synthetically. Then otherwise I might start writing up the trigonometry solution. Okay, you can give a small hint. Oh, okay. No, don't give it. Serdar doesn't want the hint. I wonder what this angle is. So that's 10.11. Okay.
EH seems like a special line.
EH, yeah. Hmm. Yeah, I was gonna. Yeah, I don't think ALPK is cyclic. No, it's close though. I wonder if this concurs. No. But yeah, I want to find something special about point L, if possible. I'm not sure. Yeah, I don't know if there is anything really we can say about point L. Maybe we could use like the isogonal line lemma because yeah, I'm wondering. So, but yeah, I wanted to try to use EF. So let's see, AP, AF, AG, and AI are like isogonal, right? So if we take FP and we let it meet IG, so it would be that point. And then FG and IP. Yeah, I'm not sure how helpful that would be. But we would use FP in that case. Kick some nuts. Sorry, I'm just snacking a little bit. So yeah, we have to use that this is a right angle. What if we extend PK?
I think we can take a hint now.
Yeah, you can put the hint in the chat. Reflect A over J. Interesting. Yeah, I'll do that. So midpoint of AH is M, and then we want to reflect A over J. So it's all the way out here. How do the orthocenter and median connect? So HG, I guess the HM theorem, right? So yeah, HM point. So let me draw that. Whoops, sorry. So JM is perpendicular to AG. So let me do this. Draw the circle BHC, and that's the Humpty point. So HN is perpendicular to AG. And JM is parallel to HN, and they're both perpendicular to AG. Okay, so we want to use point A prime. So A prime H is parallel to JM. Actually, let me see. So A prime, H, and N are collinear, basically, I think. Yeah.
Do we know that JM is perpendicular to AG?
I just guessed because I Khan said it, to be honest, but let's think about it. So because JA equals JN equals JK. Okay, so we know JN is tangent to the circle. So JA equals JK is an angle chase, but then I guess we can show that JK squared is JB times JC by harmonic reflection of N over BC lies on ABC. Okay, sorry about that. Okay.
Okay, it's a well-known property actually.
Yeah, so basically this point right here is the reflection of N over BC. Yeah. So yeah, because it's harmonic, yeah, that makes sense. So yeah, I guess we don't so yeah, we could draw this circle right here.
Can you delete L?
Delete L, yeah. PMJ. So wait, I'm still. How do we know that JM is perpendicular to AG?
AGN an isosceles triangle, and AM equals to MN.
Oh, okay. AM is MN. All right, so we want to show QMPJ is cyclic. You could try to show AQ times AJ, say AM times AP. We know let's see, what if I label this point again? So we know AL times AP is AK squared. Can we say anything about AQ? I'm not sure.
I think that I could show solve this problem, but it's kind of complicated. Just use calculate, but no, I would say the main idea.
Okay.
Okay, so we need to prove triangle AIG is similar to PAQ, right?
Okay.
PQI, right? But we have that triangle AHQ is similar to IK, right?
AHQ is similar to AIK. I'm assuming that's just angle chasing, right?
Yeah. So which means that if we write the ratio, we must prove that IG over IK is equal to AH over AP.
Okay.
Yeah, and we can calculate AP, IG, and IK.
Ah, okay. So it's okay. So it's
it is not that hard. Just you just use some ratio, easy ratio. Could you extend AI cut the circle?
Yeah.
Yes. Okay. Yes.
So DS is parallel to DC.
Yeah, that's right.
Okay, I'm gonna try to write up that method. So let me see if I get this right. So you want to show that AIG is similar to APQ.
Yes.
But we know that so some triangle is similar to AHQ. Was it
AIK?
AIK.
Yeah.
Okay, so AIK is similar to AHQ. So when you write out the ratios, you want to show that
AH over AP
Mhm.
is equal to IG over IK.
Okay.
Okay. Yeah, we're gonna calculate IG and IK and IP too. Okay. First of all, we will begin with IG. Triangle OIG is similar to ASD.
OIG is similar to ASD. Mhm.
So which means that IG
Mhm.
over OG
Mhm.
is equal to DS over DA.
Okay.
Could you write it? It could be
Yeah, definitely.
to look. Yeah.
I'm just gonna hide the other stuff for now. Okay. Does KP oh, sorry. KP pass through. Oh yeah, it looks like it. But yeah, KP. So, sorry, I was just interested in what Yash said. All right, but first let me finish up what Dat said. So basically, so we want to show IG over IK
Yes.
is equal to let's see,
AH over AP.
AH over AP.
We should write to IG times AP equal to AH times IK. Yeah, implies.
All right.
Okay. Yes. So first of all, triangle OIG is similar to ASD. So GI over GO.
So we have GI over GO is DS over AD.
Yes. DS over DA. Yeah. Okay. Okay. So next, triangle APK is similar to triangle AES, right?
Mm-hmm.
Yes.
Okay.
So that is because the angle. Just get the angle. Yeah.
They're isogonal and they're both right.
Yeah.
Yeah.
So AP over AS is equal to AK over AE. Yeah.
Okay.
Yes. And the last one is IK. Okay. So triangle AIK is similar to AED.
Ah. Okay.
Yeah.
So AI
over AE.
AI over AE.
Yes.
It's AE over AD.
Yeah.
Or
It's AK over AD.
AK over AD.
Yes.
I like this.
Yeah.
So it's just three symbol ratios. Yeah.
Yeah. You should write as GI times DA is equal to DS times GO. Because when you multiply the three things, it would be easier to look.
Okay.
Yes. Okay.
Whoops. And okay, so I guess it's getting rid of the AS. So if we combine the three of these, it looks a lot like this.
We should combine. If we let yeah, just write as the multiply. So we will
Do it for all three of them, right?
Yeah, yes. Okay. All right. There's something wrong here. Oh, I used the wrong thing. The last one is not AI over AA. It's IK over ED.
IK over ED.
Yeah, we need IK. Not AI. Yes, IK over ED.
So IK times AD is AK times ED. All right.
All right. So if we multiply the four thing, you see it, right? So let GI times DA be on the right and AP times A on the right. Yeah. So when we oh no, just it's okay. Just multiply it. Oh, okay. Now we have now we need to prove that IG times AP is equal to AH times IK, right?
IG.
Yeah.
This, yeah.
That, yes, and we have three under, yeah. So if we multiply it and we prove it is true, so we got our problem, right?
Yeah. So I think should I switch? What if I switch this just to the right side? So IK times AD.
Yes.
Hold on one sec. Let me check the chat. Okay. So first I'll do this solution, and then I'll try to see the other solution. So then we take these three, we multiply them. AD cancels and AK cancels. So if we multiply them, we would get IG times AP times, okay, so the AD cancels and the AK cancels. So times AE times ED is equal to, let's see, DS, so it would be IK
yes.
times DS times AS times GEO.
Okay. Okay, so but now we realize that OG is a half of AH.
Okay.
Okay.
So OG is half of AH.
Yes. So we just need to prove that AE times ED is equal to DS times AS divided to 2.
Yes. So is because, yeah, OG is AH over 2, and, well, yeah, what do we do with the ED? So,
okay, just write, and I will tell it. Yeah.
okay.
So we need to prove that AE times ED. DS times AS divided to 2.
AS,
DS.
DS times AS divided by 2 is, but we need an AH. Yeah. Okay.
Yeah. Okay. Okay. Now, which means that we need to prove that. Oh, okay. But DS, could you let DS cut OE?
I'll let DS cut OE. Yeah.
Yeah. Yeah. Yeah. So DS over 2 is DT, right?
Yeah. So this would be DT times AS, and AS is twice the radius. So yeah.
No. We don't need AS in twice of radius. Okay, so we need AS times DE is equal to AS times DT is equal to DE times AE, right? That is because triangle AES is similar to DTE.
AES is similar to DTE. Yeah, this is a nice solution.
Because angle EDT is equal to angle EAS, right?
Yeah, so hold on. So this is ST times AS.
Yeah.
All right.
No,
So
DT, DT, not ST.
I'm sorry, STE? STE, right?
The DT times IS, not ST times IS.
Oh, but DT and ST are the same thing.
Yeah. But we need triangle DTE. Yeah.
Oh, because I put DTE here. Yeah.
Yeah.
So yeah, let me put this on the bottom. So I'm just going to rewrite this for the viewers pretty quickly. So, and then I'll get to the second proof with I'll just say combining the above, this is equivalent to okay. So this first one is because ADS is similar to OGI. And the second one is because APK is similar to AES. And the third one is because IK over ED is because AIK is similar to AED. And then this is well known. So we'll just say, yeah, combining the above. But we still, so this would mean that, so IG, so we know AIG is similar to hold on a sec. So we want to show that QAP is similar to AIG. So yeah, I mean, really, yeah. So once I've shown this, then that means that so we have QAH is similar to AIK by an angle chase. So and then if we combine it with the above, we get QAP is similar to AIG. And then once we know that, by an angle chase, QP is parallel to AF. Yeah, there's some work to do here. I'm just going to leave it there for now. Just because I want to move on a little bit. But I like this solution a lot because yeah, like all the information you need, it should be QP. All right, so this is our first solution.
Thanks. Thanks. Yeah. Thanks for the compliment.
Yeah, definitely. My pleasure. This is a fun one. So now we'll do the second solution. Okay. I'm going to unhide some stuff. Okay, so let's see. All right. So what is the second solution? Let's see. Let me check the chat. Okay, so the circle with rate, yeah, I'll draw that circle.
It's just a circle.
Let's see. Since, okay, so P, K, and A prime are collinear. That makes sense. And then, how do we, okay, QHPA prime, we want to show that that's cyclic. And that I think is probably just an angle chase, right? Because we just need to, yeah.
Oh, I think this solves the problem.
Okay.
Okay, so like Hakan said, we need to prove that QHPA prime is cyclic.
Okay.
Yeah, that is angle chase because angle AA prime P is equal to angle OAK.
Okay.
Yeah.
OAK.
Yeah.
So,
because OA is the tension.
Mm-hmm. So angle AA prime P is angle OAK.
Yeah. Yeah, but OAK is H is PAK because OA yeah. Yeah,
Okay.
and PAK is equal to QBA because it is equal to QHA because QH is parallel to AK. Yeah.
All right.
That's a nice solution. I don't even think about this.
So okay, so this means that QHP prime A is cyclic.
Yeah.
And then once we know that, sorry, or QHPA prime cyclic. And so PQ is basically anti-parallel. Let's see. Actually, and then from here, is it kind of just an angle chase? Because I guess we want to show angle QPA, or maybe Hakan already did it. So APK.
For that, you also need to show that A prime H is perpendicular to AG.
A prime H is perpendicular to AG. Yeah.
But
so
that is also, but we can also do that by redefining points as N is the perpendicular from H to AG, then N is the Humpty point and it lies on the Apollonius circle. And so N lies on the circle, or N lies on the circle with radius JA. And then since A prime is a diameter, so we are done that A prime H is perpendicular to AG.
I thought about it differently. So first we could prove that JM is perpendicular to AG, because so MA is MN and also JA equals JN. So basically JM is perpendicular to AG. I think this is what Hakan said. And then since J is the midpoint of A prime A and M is the midpoint of AH, then A prime H is perpendicular to AG. So yeah, I think you had a different answer. So N is the Humpty point. And then what were you saying about?
It is a property. Yes, it is a property of the Humpty point that it lies on the Apollonius circle as well.
The Apollonius circle.
Yes. A Apollonius circle.
Oh, okay.
The circle with radius JA.
With radius JA. Okay.
And since A prime is a diameter of that, so A prime H is perpendicular.
Okay. So we know this. from that, because yeah, it's a property that n lies on this circle with radius JA, and then once we know that, is it just like an angle chase from here to show that PQ is parallel to the AC medium?
Yeah.
Okay, I'll just write that for now, just so that we can move on to other problems. But it seems pretty interesting. All right. All right. This was fun. Everyone had like contributed different ideas here. So here's the next problem. Oh, this one looks a little bit harder. You guys, I guess I'll go through with it. So you have a triangle ABC,